Yes, record the meeting. Okay, sorry about that. If you were not here at the beginning, you just missed 20 minutes of me talking. So consider yourself lucky. But now we've got everything recorded. So sorry, I will make the recordings available also on D2L. So you can see that getting into D2L is kind of really important. So what I will do is, at worst cases, I will email the person who's in charge of this and say, hey, give these students some instructions how to get logged in. Okay, and then what I will do is I will take 20 minutes tomorrow and I will explain some of the important parts out of D2L. All right, so here we go. That is the first thing. Okay, perfect. All right, back over to here. So you can see, welcome to Python, name Zara, hello. And of course, if I printed this, we'd see hello followed by a space, followed by the name of the variable, which happens to be Zara. All right, next one up, the input statement. Okay, as I said before, obviously you guys have been through some programming before in other languages, and yeah, being able to interact with the user is very important. Um, Ultimately, however, if you guys go off and you deal with either cybersecurity or AI, you'll almost never ask the user for anything. Most of the time, you'll be pulling data from a file, but I was told that a file is outside the scope for this course, so I don't have to cover it, but you might want to go and you might want to read about how you read stuff out of files. All right, but in any case, input. So yes, we will have some interactivity. So here we go. How do we deal with this? Okay, so again, for those in C++, we're talking about one of these things. Okay, variable. Okay, there you go. If you're in JavaScript, well, there isn't really such a thing in the world of JavaScript other than document, get, element, by ID, and some control followed by .val. That's about the closest thing we have to an input in there. If we're talking about Java, you're usually talking about something called a scanner. Okay, that could be bringing back some nightmares for people. And in the world of PHP, I guess in the world of PHP, you might be picking up a variable and it's probably coming from a form using like a post. So you'd probably have something like this form field. So something like this. That's the equivalent of input. Okay, in the world of Python, the input statement is pretty simple. It's called input. Okay, and here's what you do. The input statement takes a string as a parameter. Okay, and usually what you do is you store it into a variable. So here we go. So line number one of my program, this will block the program from running and it will set an input, of course, with a character prompt where you can type something. All right, so if we type 1, 2, 3, 4, 5 and press enter, you'll see that the data being put in is 1, 2, 3, 4, 5. Okay, excellent. And yeah, so something that's a little bit odd in the world of Python compared to, I'm going to say the C++ and Java people, so sorry, this is a bit weird, is what is the type of data? Well, that's pretty clear. You look at that and you go, well, it looks like an integer to me. I don't see any decimal points, so it's not a decimal, it's not a float or an int, or a double, but it looks like an int. Okay, but you know what? It might also be a string. Now, I've got something very, very important that I have to show you. Okay, here we go. You're going to learn a couple of extra things. For example, there's something in Python called type. And what this will do is this will tell me what type something is. Okay, it prints out a very, very simple little string, and it will tell me what it is. So if I type something like hello, immediately you would say, yes, and again, since you guys have had some exposure to programming, you say, well, that has to be stored in a string. All right, and of course, well, what you end up seeing is you'll see the word str, and of course, that's an abbreviation for string. Now, for those in Java and C++, and perhaps in JavaScript, depending on what you've done, and maybe even with Python, yeah, there are classes. Everything is a class in the world of Python. We don't cover object-oriented programming in this course. This is really just a very, very quick syntax, but you're going to see some stuff that will remind you very much of classes, okay? And this is one of the things that will show up. So yes, this happens to be a string. Okay, makes sense because I typed the word hello. Well, if I type the number 1, 2, 3, 4, I don't expect to see the word str, but you know what? We do. All right, and here's the deal. You see, an input function always returns a string. Okay, it always, always, always returns a string. Now, here's what I'm going to do is I'm going to write a little program, okay, and I'm going to have two variables, a variable called one, and I'm going to say input, enter first number. And I'm going to have another one called two, and I'm going to say, oh, here we go, enter second number. All right, now, I think most of you, okay, almost. Okay, quick little thing now. All right, for those who have been involved with C++ and Java, you're looking at this going, that's a mistake because this right here means one character in my language. And yes, that's exactly it. In the world of Python, this means a string, this means a string. Okay, you can use them interchangeably. Well, almost. I can't do this. Okay, if I try doing this, that will end up being a problem because you can't mix up a double quote with a single quote at the end, but a single quote and a double quote, no problem. Sorry, I've got too many things in here. Not paying attention to what I'm doing. All right, you see, this works without a problem, but the mismatches don't work. So you can use whichever you want. Why would they do this? Well, just convenience. Yeah, Java, sorry, JavaScript and PHP. Yeah, I've been using this for a while. Just use whatever happens to be most convenient. All right, here's the important thing. Let me stop this one. Okay, here we go. What I want to do is I want to have a result, and I would like to take 1 plus 2, and I'm going to print the result. Okay, and we're going to say this. The sum is, comma, result. Okay, so here's what we're going to do. Let's run it. Okay, so let's add a 3 for the first number and a 7 for the next number. All right, and well, okay, I know it's middle of summer, maybe it's late in the day, maybe you're tired, but I assume you can figure out what 3 plus 7 is, and of course, well, the answer is 10. Until you run the program and you get 37. All right, you have to remember what this was. Remember the type of 1 is a string, the type of 2 is a string, and when you take two strings and add them together in Python, you get string concatenation. All right, those people in PHP, yeah, you have that. It's a dot operator. Actually, I think it also supports plus now. If I remember, I think Java supports this, but of course the C++ people may be looking at that going, what? Okay, but I just can't remember whether or not C++ supports the string concatenation with a plus. I come from the days of C. Okay, that would be completely insane to do this. All right, so unfortunately, what it does is it takes the string containing 3 and the string containing 7 and jams it together into a single result called result. All right, so here's the problem. If you really want to add those two values together, and we know that the input happens to be an integer, unfortunately, what you need to do is you need to do typecasting. All right, so again, some of you will have seen this in other languages. For example, if you're in the world of C++, you would do something like this to cast it. Well, you wouldn't be able to cast this one. But the good news is it's a function here. And all that you do is the function is called int, and you stick the input inside it. All right, so in a Python program, you see all kinds of stuff like this. So here's a 3, here's a 7, you add it together this time. Perfect, we have a 10. Now, I would like to clean up my output a little bit. I would like to have a period at the end because it's a full stop. And of course, if I run this, here we go, 3 and 7, you'll notice, no, my students that I get in INFS 1201, they always say, yeah, the output's fine, it's perfectly fine. I go and I take a mark off and they go, it's not fair, the output's correct. And I go, yeah, but I really don't want the space here. And if you look closely, yes, there are two spaces here. So first one up is you say, okay, fine. I can get rid of one space by removing this one. Okay, so 3 and 7. Okay, 4 and 7 doesn't matter. But this one right here, there isn't a space already. And no, this has absolutely no impact whatsoever. Okay, the problem is that it's just sticking extra things. Now, if you were paying attention earlier, hopefully you were, you will have remembered that, well, I know what it is. I'm supposed to have this thing called separator. And if I said that there's nothing, it means that I can do this. So 3 and 4, and sum is 7, full stop. Excellent. That's what I want. Now, the thing is, the number of times that you're formatting things like this, okay, I'm going to show you at least two other ways how to deal with this. All right, so for those in, I'm going to say every language except for, okay, JavaScript and PHP has got something a little bit different. All right, but if you came from the world of C++ or Java, this is the way how you would probably approach this. You would say, well, I'm just going to use a plus operator. Here we go, plus, and I'm going to pull full stop right here. And that looks like it's going to be perfectly fine. All right, so you try a 3 and you try a 4. Of course, it should be 7. But unfortunately, instead of getting an output, what you end up with is a complaint saying you can only concatenate strings to strings and not to ints. You see, the problem is that result is now an int. This is a string, this is a string, this is an int. You can't concatenate these things unless you use some more typecasting. Okay, so something like this will do it. Here's my 3 and 4 again. Now we've got it back. All right, do you consider that to be better than what I just showed a few seconds ago by using the separators equal to empty? All right, I think it's not really helping very much. Of course, somebody who's done a little bit of work in PHP would be looking at that and saying, ha ha ha, I know what I would do. I would just stick a $sign and I would say that. Okay. Unfortunately, if you stick a $sign here, it actually shows a $sign. But because we're constantly doing these things in Python, yeah, they've allowed something like this. The format's a little bit funny. Oh, for those who have seen some JavaScript, okay, JavaScript, you would have another quotation mark called a backtick, and you would do something like this. That's what you would do if you happen to know JavaScript. Okay, well, again, this isn't JavaScript. This is just Python. So what I'm going to do is I'm going to put a quote. And by the way, this works with single quotes or double quotes. And all that I do is I stick an F in front of the very first quote. And what I've produced is something called an F string literal. All right, it doesn't require $signs. It just works like this. So here we go, and 5 and 6, there's an 11. So there's the way how you can deal with these outputs. Okay, excellent. Okay, so there you go. Yeah, I've probably diverged. I've probably covered like almost everything that I need to cover through most of this. All right, so excellent. We've got some type conversion. I've talked about that. That's really, really useful. Okay, let's see. What type is it? Very, very important. Oh, okay. I guess we have to talk about the types. I think that actually shows up on my next slide. Is just looking to see what's coming up next. Let's output variables and name. I'm just sort of scanning forward to see what we've got. Okay, excellent. I might cover something that'll actually be covered like in a later one. All right, the main types of variables that we have here. Okay, we better learn. Oh, something very important, by the way. So for those who have only seen C++ and Java, you may have noticed that I'm doing something really kind of odd, and it's going to work like this. Let me write a simple little application just to add two numbers together, and I'm going to write it in Java. So give me a second. So here we go. Public class blah. Okay, the syntax highlight is going to look really weird. Public static void main string args. Okay, and if you've never seen Java syntax before, don't worry about it. But all right, perfect. Okay, besides the fact I'm missing all my stupid semicolons. No, semicolons are not part of Python. If you put them in, there's no penalty for doing it, other than it just kind of looks weird. Okay, so yeah, we don't use semicolons here. But sometimes I might accidentally take them in because if I'm working in another language, I might just forget what I'm doing. All right, so here we go. This is a program in Java that defines two variables. All right, I've got three variables, 1, 2, and total, and the type of 1 is int, the type of 2 is int, and the type of total is also int. And of course, if you do something like this in the world of Java or C++, it is going to complain a lot and it's going to say, no, you cannot do that because you're trying to use the variable before it has been assigned. On the other hand, Python, you don't need to declare your variables. To declare a variable, all that you do is you simply use an assignment statement. So total is equal to 1 plus 2, and we'll print the total, and that's it. So that's a little bit surprising because it is quite different than, say, Java and C++, where it's a strongly typed language. This is not a strongly typed language. You don't need to define variables. You basically create a variable by basically just assigning it. All right, now here's what I'm going to do. I'm going to print the type of 1, the type, the type of 2, and the type of total. Okay, and then I'm going to print out the value total. Let's run the program. Ooh, print. Sorry, missed that one right there. Here we go. So take a look at this. We got 1, 2, and total. Int, int, and int. Well, that makes a lot of sense because it's 34. It's not 34 point something, it's 34. And an integer plus an integer is an integer. Okay, excellent. 34.5. Okay, take a look at this. You see, 1 has now turned into a float because it is 34.5. And yeah, that's what actually makes it a float. Put a decimal point. 2 is still an int because it doesn't have anything. And of course, the total, when you add an integer and a float together, well, you have to go to a float because the result is going to be 44.5. And even if I do something like this, yeah, it still is a float because I've got the decimal 0 at the end. Okay. Now we need to look at some other things. Okay, so let's put some spaces here and we'll have some more variables. Okay, name. Now we have different types of variables. Do we have different types? Ooh, yeah, I might be doing something that I'm not supposed to do yet, but anyway, it doesn't matter. It doesn't matter. You know what? I'm here, and here's what I'm going to do. There's a string. Okay, that's a string literal. And guess what? If you type the type of name, that is an str. Okay, very good, very good. So now, so for those who've been through JavaScript, you're looking at this going saying, yeah, that's completely obvious. This is exactly what we do there. Yeah, that's exactly it. If I try to run a program like this, I end up with a big problem. Okay, I end up with a problem that I can only concatenate things. So here's what I'm going to do. I am going to, I guess there's nothing else that I can do. But you know what? If I was to print, okay, the problem is that my program crashes here, so the rest of the program doesn't continue. But if I try printing the type of 1, guess what? It's a string, str. If I try printing the type of 2, that will say integer. And if I try type total, that would be what? Well, what do you get if you take 34 and you add 10? Well, you don't get anything. You can't do it. You would have to do some kind of casting to be able to turn something in so you could actually do a calculation. Like, for example, I could do this. Okay, this would be 34. It's because it's an int. Sorry, get rid of this one. You see, this would end up working. 1 is still an integer, or sorry, is still a string. But when I said try to calculate the total, I said, okay, take 1, turn it into an integer locally, just on the line, turn it into the number 34, then add the variable called 2, which is actually 10. Sorry, I should have picked better names than this. All right, so there you go. There's some very basic stuff about typecasting. Okay, hey, we're not doing bad. We're not doing bad. This might actually give me like a couple of extra minutes. Okay, that'll be surprising. Let me get back to my slides. All right, so here we go with built-in type function. Yeah, and by the way, I actually recommend you use this like quite a bit. Whenever I have students who are stuck in my intro programming course and they say, how come this doesn't work? I say, well, why don't you print out the type? Because if you can look at the type, you get a better idea about what's going on. Sometimes things can be just a mistake because you forgot to typecast it before converting it. Okay, you know what? Since we're here, let's actually try this program. Oh, that's actually pretty cool. All right, so the program right there, I said original is equal to input, enter a number. Okay, and then print type original. Okay, and I'm going to say converted is equal to float original. And then I'm going to print type converted. And I'm also going to print converted itself. Okay, because very, very important. All right, so if I pick a number like 45.6, okay. All right, that's where it stopped right now. When I press enter, I'm going to print the type of original. So what type is that? If you said decimal, you're wrong. Or float. And by the way, there's no double, just float. No, because an input is actually a string. All right, so the first one's going to be a string. The next thing that I do is I try to take the string and I try to convert it into a float. And if it works, when I print out on the second output, we should see float. Okay, and then we should see the actual value. So if I press enter here, you'll see that the original thing was a string, then it got turned into a float. Okay, excellent. That was the converted. If you put in something that is not a float, well, then you actually saw the mistake happen a few seconds ago. It says that we can't convert the string into a float because, well, we've got a dot R at the end. Okay, so if you try to include extra letters, the only letter or character that would be allowed would be something like this. Okay, that's obviously going to be okay because that is a valid input. The only thing that is a little bit weird, there is actually something called inf. And it actually works. And what that is, that's an abbreviation for infinity. It's not something that we use very often, but sometimes it's very, very helpful. If I can find some reason for including it, I will try to cover it. But basically, infinity means this is a number that's bigger than any other possible number in the system. Okay. All right, so let's get over here. So that's really kind of the only oddball one that works out. Oh, and by the way, if you try something like 3 minus 4, no, that doesn't work because 3 dash 4 is not a float. Okay, it's not doing any type of calculation for you. All right, so as I say, you can use the type function for troubleshooting. I use it all the time in my intro course, mostly to show students what we're looking at. Okay, complex output with concatenation. Oh, well, the cool thing is we already did this. Yeah, you concatenate a whole lot of things. We have a bill number and a bill amount, and you build up this big long string. This is exactly what we would end up doing in Java and C++ from, well, I guess the 15 or 16 years ago, or still if you're using Java these days. All right, complex output with F strings. Okay, excellent. So you can see how you can really clean things up using these F strings. You just have to remember. Okay, yeah, let's do this one. Okay, because this is one that my students get into a problem with. All right, name, input, name. Okay, we're going to ask for a name. We're going to ask for an age. That's an input. Okay, what is, just age. Okay, but of course, that's a string. That's kind of reasonable because inputs are strings. The age, on the other hand, is probably an integer. So now, by putting this, of course, we run the risk that the program could crash if the user goes and types some random junk. All right, but in any case, here we go, name of the age. And then what we're going to say is name will be age plus 5 in 5 years. 5 years, full stop, then. All right, here we go. And of course, well, I want it to be an F string. Okay, so me and my age is 16 years older than when I came here. So I'm going to lie and say it's 34. And you know, you're definitely not true. So me will be 39 in 5 years. Of course, it's all lies, but that's the way how we use this. My students in the intro course usually end up forgetting the F. And when you do this, it doesn't actually interpret those things. It just simply shows you what's there. So yeah, the F is really kind of important. Again, single quotes, double quotes, it doesn't really matter. The slides are also talking about something else called a triple quote. Okay, we better do this. Okay, here we go. Long string. Okay, all right, here is a very long string. Ooh, do I have a very long string at my disposal? PowerPoints. No, I've closed up all my strings. Ooh. Okay, you know what? Sorry. I don't like doing stuff like this for just randomly typing junk, but this will be fine if I print a long string. Bang. There you go. Yeah, the output wraps. The problem here is that the output doesn't wrap and you can't see the rest of it. So your first attempt may be, well, let's just press enter. But of course, the problem is if you press enter, well, now you don't have a string anymore. And if you try running this, it says, yeah, unterminated string literal because it reached the end. Okay, now, if you do a bit of reading, you might find that something like this works. Okay, yeah, it's a backslash. This simply tells you that, yeah, please continue this on the next line. This is one way of having a big, long, multi-line string. Use backslashes as the very last character. You'll notice that the backslash is not part of it. It really is just to show you that, yeah, this is a string. All right, we have some extra things here that are really, really handy in the world of Python. We have a triple quote. Okay, now let me watch. Yeah, type a bunch of stuff. One, two, oops, sorry. 1, 2, 3. 1, 2, 3. All right. Notice that there's no syntax here. When I print this, you see what I've got? This whole big long thing from the beginning of triple quotes to the end of the triple quotes, that's the string. Okay. And that's what just got printed here. Yeah, we use this whenever we're writing. We use this for a couple of reasons. If you're writing really long strings that you're trying to build up that go across multiple lines, this is exactly how I do it. The reason why I do this, okay, if you guys have ever done database programming, you might have something like, let me see, program count star, and just so I got a couple of extra things. Don't worry, if you don't know what I'm doing, it's completely fine. I'm just demonstrating why we might have a multi-line string grouped by program. All right, right there, that is a multi-line string. I run queries like this all the time. Okay, I write queries up this way because it's a lot easier for me to read when things go across multiple lines, and I don't want to put the backslashes. Okay, that's what we use multiple or triple quotes for. Yes, it works with string replacement as well, and you can ask for things like this. Okay, all right. Here, copy this, go away. All right, back over to my slides. Okay, how are we doing? Oh, I'm almost out of time, but the good news is I'm basically out of slides. All right, you guys already know what variables are. Good, I don't have to say anything about this. Obviously, names of variables are kind of really important. Okay, and yeah, don't use single letter variables. You will never see me do this. I might do it once just to remind you, yeah, don't do this. Use at least a somewhat easy to remember word about what it means that you're storing. Don't use X and Y. You guys have seen lots of programming in other languages, so it shouldn't be so terrible. All right, same rules. You can use space, or sorry, you can't use spaces, but you can use underscores for spaces. Don't worry, you'll learn as I go because I will use lots of variables like this. And there's a bunch of words that are not going to work for you. For example, if you try to say def is equal to 34 and print def, that's not going to work because DEF happens to be a reserved word. Anything in my editor that shows up as orange is a reserved word. Shows up same colors in idle. All right, and there's a bunch of things that show up in purple function and purple values for as well. For example, if you take a look, sum is equal to 30 and you print sum, this works, but if you look very closely, let me zoom in as much as I can, you'll notice that there's a big difference between sum and other, and the difference happens to be the color. Yeah, it is actually really, really important. Purple means it's a function that's built in. You really shouldn't use it because the problem is if you use it, well, then you can't actually use anything. For example, this right here is actually valid Python. You set print and then you print. Of course, it doesn't make any sense because now you can't, because now print is an integer and you can't print anymore because now print doesn't mean print anymore. It means an integer. So if you ever see a variable show up with a purple color, just don't use it. Okay, that's kind of my best way. All right. Ooh, 4:51. Okay. As promised, there will be a 10-minute break. Here's what I want you to do during this 10-minute break. Now, I can't force you to do it. If you have not tried logging into D2L, so it's d2l.udst.edu.qa, log in with your ID, provide your email password, and see if you can get logged in. If you can just leave it for the chat window just to let me know whether or not you got logged in. Okay. And meanwhile, what I will do is I'm going to put myself on mute for 10 minutes. or maybe 12 if it ends up being. And then I have to try and work on something very quickly so you guys have access to the Python interpreter, and I also have to go get myself a tea. So we have 10 minutes starting right now, and I will see you at 4:53. Okay. Okay, and mute so you don't hear me swear when I can't get my program to work. Okay, I am back. Hopefully you're still here. It could be back in the days of COVID. I think I spent a lot of time talking to myself, where people would wake up, especially 7 in the morning, and just log in, and I think they would just go back to sleep. So um, I think I'm supposed to poll you occasionally, make sure you're still awake and here. But in any case, don't worry, I won't be doing that. All right, excellent. So, what I have done is I've sent you a link in the chat. Um, I would appreciate it if you copy and paste that just to give it a shot. But of course, replace this with whatever ID number you happen to have. Okay. The reason for that, it just tracks because every request that comes in, I just record like who's using the system. And obviously, if you leave it as my ID number, it's going to look kind of weird because obviously I'm not the one who's doing it all. All right, now give me a second because I have to switch over slides. Normally, I would have this done a little bit sooner, but it took me a few minutes to remove the restriction. So I will put the restriction back, by the way. Okay, here's the deal. I will leave the restriction off until what's the date? The 28th of August, I think is the date, because that's when our new semester starts, and I had to put the restriction back. 24th of August, this will be gone. But I think this may be at the time when you have your final exam anyway. I'd have to go back and take a look at that. All right, lecture number one done. Okay, lecture number two. Okay, here we go. Excellent. This is operators and expressions. Again, it might be really quick because, as I say, everybody here has got some stuff. So excellent. Okay, and thank you for letting me know about the D2L. I will send a message and say, hey, you didn't tell people that their accounts were actually activated, or maybe they didn't activate them. I suppose I could go and look at that. Mm. Okay, what do we got? Note to myself during next break. I'm busier during the break than anything else. All right, here we go. Check counts in D2L. I'll find out whether or not they have been set up correctly, or maybe they've been set up as a local account. I don't know. I won't be able to change them, but I'll take a look and see whether or not it looks kind of normal or something's really weird going on. All right, so here we go. Operators and expressions. Okay, so what do we mean by operators? Okay, operators are things like addition, subtraction. Okay, those are operators. And of course, expressions when you want to put together a whole bunch of things, a whole bunch of operations together. That's an expression like A plus B divided by C, that type of thing. Okay, so that's what we cover here. Very, 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 very quick stuff. And I've got even a Python programming exercise at the end of this one. Excellent. Ooh, okay. Yeah, okay. Obviously, if you're accessing from a phone, you're probably not going to be able to type any programming here today. All right. Well, in that case, you'll be kind of partially excused from the Python programming exercise at the end. So I do have a small exercise. I'll get you guys to try things. And by the way, if you happen to have downloaded IDLE already, or you already have a Python environment, by all means, use that one. Okay, you don't have to use mine. All right, but in any case, here we go. So slide for this one, operators and expressions. Okay, first one up, the numerical types in the world of Python. Okay, we have an int. Ooh, okay, so here we go. Now back over because I have to do something very, very important. Um, let me see. Let me see. This will be fun for those who have been in C++ and Java. You would have been taught that an integer, say total, has a limit. Okay, the limit is pretty big. Like, for example, okay, that number right there, that's not a problem. This number right here is also not a problem. However, a number like this in a Java application or a C++ application, as soon as you try to do this, everything would blow up. Well, here, um, it just works perfectly fine. And you go, oh, so, all right, so in that case, where's the limit? All right, so let's add some extra stuff, add some extra stuff. So I'm adding, that's a really, really big number. And when I run it, yeah, it's just perfectly fine. Right. And the reason why this isn't, or why this is kind of weird is because programming languages back in the early days of computing would always have some kind of a limit. It could be an 8-bit limit. It could be a 16-bit limit. Could have been a 32-bit limit. When I first learned how to program, integers had 32-bit limits. These were really, really limitations. You couldn't have a number bigger than 65,000. It was really quite annoying. But here, you can basically have whatever size number you want. You want to add more digits to it? Oh, sorry. We can't add that. That won't be an integer. You want to add more digits to it? No problem. You just keep adding more digits to it. Here, you want to add some more nines at the beginning so it really stands out? Okay, apparently I haven't got a repeat done. Yeah, it just keeps on going. Well, how does it do it? Well, it does it at the expense of it takes a lot of memory. It just takes more memory. That's the deal. Okay, so that's what we're getting is we're getting a trade-off for memory and of course for performance. That's the one downside to Python. In terms of performance, it's not very good compared to Java and C++. Those will be much, much better in the world of performance than any Java program ever. But people have developed some really cool libraries that make Python faster if you use them. For example, you will be learning about something in your data science course called NumPy. And inside NumPy, you've got all kinds of things like these data arrays and so on that are very, very efficient and much, much faster. Okay, but that's for your data science course, not for here. Okay, next one up. Okay, well, we saw this before. Okay, somebody's test score. Okay, ooh, a test score. All right, fine, test score. Oh, and by the way, it's spelt this way, test score. It's not spelt this way in the world of Python. Okay, that wouldn't be used anywhere, but I suppose test score would likely be used in Java and C++ applications. But in Python, it's pretty customary to use lowercase letters. And underscores between. This is called lower snake case. All right, so here we go. I suppose it's completely conceptual that at the end of this course, you could end up with a, let's see, I want to pick a decent number. I don't want to freak everybody out and say, here's your score. No, 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 no. What do I pick? Okay, we'll pick something like an 83. Okay, and print test score. Bang, 83, not a big problem. Now, 83.5. Yeah, well, now it becomes a float. That's not an issue. 83.5000000. What happens when I run it? Well, it just gets rid of the zeros at the end. But if I stick a 1, bang, there you go. Yes, obviously this ends up working. But now here's an interesting thing. If I had a few extra zeros, it continues to work. I had a few extra zeros, and suddenly that didn't quite work. Huh. You see, it works here with that many zeros, but if I had one extra, it seems to lose it. Well, that's because in the world of floats, you can only store a certain number of digits. And the number of digits happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, 17, 15, that's the actual number of digits that you can store. And it doesn't matter where they appear, okay? But you just can't have that many. All right, like for example, I could do this. 86. Now, if I told you that's your test score, you're going to say, yeah, it's a 0 because it doesn't store that many. Actually, that's only 2 digits. The 8 and the 6 are the digits. Okay, and that actually gets stored in floating point format. 8.6 times 10 to the power of minus 27. Okay, so remember your math. What you would do is you move the decimal point forward, backwards to turn it from this to this, 27 spots, which of course you count that up. That better be 27. Okay, I won't count it. I'm pretty sure the computer's correct. All right, so that's just one of the downsides. Second problem with these things, of course, is if you take a number like this, of course, you suddenly realize that, oh, hey, yeah, that's 3.33333333. But look what it did. It's like a 6 at the end. And that's not right because it's supposed to be 3.33. It's supposed to be threes forever. But of course, it can't do that many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Sometimes you get 17 if the number's not big. But instead of rounding it or truncating it, it just seemed made up stuff. And yeah, that's this can happen. Other is 100 divided by 3, and blah is 100 divided by 3. And of course, if I take this test score plus the other plus the blah, that should be 100. But when you do it, oh, look at that. It actually came up to it. A little bit surprising. By using the 0.6s, that's probably why it did it. All right, but in any case, one thing that's very, very important is when you're dealing with floating point numbers, you'll never get exact values. Best you can hope for is close. This one, hey, we were really lucky. Okay, so is it a limitation of this particular interpreter or Python in general? Thank you. At the moment, the Python standard that this one is based upon, which I think is a 3.7, those were floats. It's a 32-bit. No, sorry, I got the wrong one. It's a 64-bit IEEE standard, and that's what they use for floats. If you don't like floats because of the accuracy problems, then you have to use something completely different. Okay, but the problem that we have is this. What we're running here is exactly the word that I see, which is an interpreter. Okay, now that's a very interesting thing. I have people in here who've seen C++ before, and that's good. I like that. And the reason why I like people who've seen C++ before is because you understand that when you write code, the code itself doesn't run. It gets compiled to machine code, and the machine code gets run by your CPU. Okay. So we don't have that type of business going on here. In the world of Python, it is an interpreter and it happens to be interpreting. And yeah, every version of the interpreter could change. But at the moment, as far as I'm aware, the 3.7s, 3.10 Python interpreters are all based on the IEEE standard of a single storage, which is pretty limited to 15 digits worth of accuracy. If you have more accuracy that you need, we have other types. For example, there is something, let's see, and I have to remember how to do this. I don't do this very often. Decimal, import decimal. Somebody said, well, you know what? We might need something like this. And maybe we need maybe we need numbers like that. And yeah, you can, if you try printing this right now, you'll see that it truncates after, of course, the 15 decimals. If I remember, I believe that I can turn that into a string and wrap it within a decimal, and then suddenly I have more accuracy. So if you really need a lot of accuracy, you bring in this thing called a decimal. Okay, so there is something here. It's really quite handy if you need really, really, really high precision stuff. Now, you might say, oh, yeah, that's a very, very important. We have to mark this down. The number of times that I have used decimal, let me think now. I believe that the number is now 2. Okay, I just did one right now, and I did one just a little bit before. Okay, oh, excellent. And somebody's asking, can a double be used? Okay, here we go. X is equal to 4. Okay, now print type X. Okay, excellent questions. I like this. How do you turn it to a double? Well, no problem. You take the word double. No, it isn't actually here. That's exactly what you would use in Java and C++. Okay, but it just doesn't exist. You can use that decimal that I just showed you. Does anybody ever need it? Probably not. Probably not. Do remember that the stuff that I did work on a long time ago was called numerical analysis. Actually, spent a lot of time working on this, and basically, if you work your calculations in the right way, you can minimize the amount of errors. But you're absolutely right. If you need more stuff, you need a different type. It's not double here, it's decimal. Okay, but I mean, it's cool. Here's another interesting one. Let's see, where did this go? Okay, I think I've got one coming up here. A long time ago when I first started, I said, yeah, I'm going to be an electrical engineer. That's what my plans had been. I started in university. I did a couple of years. I would have done some circuit analysis, and we do some really, really weird things in the world of okay, I got to write down the formula to remember. You have this thing called current, and then when you get into AC circuit analysis, you get not just regular numbers like 12, but you get like 12 plus 3i. What it is that they're using complex numbers. Python was very, very convenient, other than instead of using I, they use J. And you can actually do things like this. You can say current is equal to this, and we'll call it impedance. Impedance. dense, I think is how you spell it. It's been a long time. Here's another one, 10 plus 2J. Okay, take a look at this. Watch this. Print current, 12 plus 3. Okay, fine. If you add the current plus the impedance together, bang, it actually knows how to add the real parts and it knows how to add those things. And if you've ever worked with complex numbers, you know how much of a pain in the neck doing a division happens to be because you have to do weird things. You turn it into polar format. You have to do some convert things to angles and so on. But this actually just knows exactly how to deal with this. Okay, so very, very useful. Number of times used for me, twice, just before the class and just now. It's hardly something I use, but it is here if you're ever doing something that involves complex numbers. It's built in, so it is helpful if you've got it. There's one final one. So let's see. Oh, you notice I was doing some stuff. I said from fractions import fraction. All right. For those who have been in Java, yeah, you know what I'm talking about, right? So we're talking about import, java.util.scanner, this type of thing. If we happen to be C++, we're talking about include math. Okay, you're a math.h, depending on which one you're interested in. That's bringing in an extra library. The problem is that only brings in a header, and then you got to make sure you link your setup. We don't worry about that in the world of Python, but there's a bunch of libraries. There's the library called fractions, and I'm asking to bring in the fraction function or the fraction object actually. All right, and take a look at this. A is equal to fraction. Fractino? No, fraction. Here we go. Um, there you go. There's a fraction of 1/2. B is another fraction. 2/3. Okay, print A plus B. Now, remember what this is. This is the big, horrible thing where you have to find the common denominator, blah, blah, blah. Yeah, it just knows how to do it. Okay, and again, really, really useful if, okay, if you happen to need fractions for something, it's built in. Okay, so it is really cool. Number of times I've used, one. I just showed it to you. Honestly, I've never used it. Okay. All right. But in any case, that is pretty cool. So I'm just looking here on the side to make sure I haven't missed anything. It's in the slides. I included the slides in the chat. So make sure to download it before I finish off the lecture at 7 o'clock. Just download it at some point. It'll be in D2L whenever we get that set up. Okay, we got that one. Okay. So here we go. So some new things. So here we go. Oh, I told we're not supposed to be using these silly things. All right. Usually when I'm demonstrating operators, I tend just to use simple little things like A's and B's, just because it's going to be a lot quicker. Okay, here we go. Result is equal to A plus B, print result. That's not a trick question. You better be able to tell me right now what the answer is going to be when I run this. You don't have to say it. You better say it to yourself. You better come up and say, yeah, it's 34 because, or sorry, 44 because it's 34 plus this. Yeah, that's big surprise. The plus means plus. Excellent. Nothing weird about that. All right. Oh, something I better do. I had better print the type of A, the type of B, and the type of C. Oh, sorry, the type of result. Result, if I spell it correctly. Ints, ints, and ints. Okay, fine. I showed you earlier, if I take this and I turn it into a double, okay, but then the result also becomes a double. You know what? Begin with right now, just ints will be fine. All right, here we go. Subtraction. Okay, dash. Yeah, not a big surprise, it's subtraction. Okay, 34 minus 10 is obviously 24. The result is an int. A and B's are ints. Okay, not a big deal. All right, next one up. The star, of course, means multiplication. Yeah, 340. The result is an int. And again, the cool thing is that you can have as many decimals, or sorry, as many digits as you want in the integers, not decimal. The same thing still applies. If one of them is a double, then the result also becomes a double. Okay, here we go. We'll put that away. All right, now this one starts to become more interesting. All right, A slash B. All right, immediately you think division. Okay, and that's exactly it. Now, if you have been through, I gotta remember my rules. All right, if you have been in JavaScript, you look at that and you go, hey, yeah, it's 3.4. All right, if you're in PHP, I actually can't remember what would happen. I'd have to try it. But if you were to do this in C++ or Java, you would end up, well, you could use your calculator very quickly. Here you go, 34 divided by 10. That's what you get in a calculator. You would have been taught that when you have an int, a divide by an int, you get an integer as a result. And what we do is we truncate everything that comes after the end. So the only thing left is a 3. But that's not what happens here. Okay, here, clear that one. Bang, just to make sure. I actually got 33.4. Ooh. So A was an int, B was an int, and the result was a float. This is how the division operator works in Python. No matter what you take and divide, even if it can be done exactly evenly, it still turns into a float. Okay, so always, 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 it's a float. Oh, but that's not what we want sometimes. Sometimes we want to truncate everything. Okay, in the world of Python, we have a new operator called slash slash. All right, and what this is, now if I show you this, you'll say, hey, yeah, that's doing what I want. That's integer division. All right, well, this is an integer division. This is actually called floor division. Okay, and this one is a bit surprising, but it's the type of thing that you want. Okay, now I have to explain what a floor is. Okay, before we get into a floor division, I am going to import the math library. Okay, so this is like include math. I guess you wouldn't have to bring this in. Yeah, there's a math one in Java. It's been a long time since I've used it. But here's what I'm going to do is I would like to have just an extra thing here at the beginning. I'm going to say x is equal to 34.5, and I'm going to print math.floor x. All right, see what it does is when you print out floor, it seems to get rid of the stuff after the decimal point. The rest of it's still the same. All right, and that's not incredible. That's not exactly accurate. It's very, very close to what happens, but we have to be a little bit more careful. All right, here's what it does. It finds the integer. It finds the biggest integer, which is less than this number. Okay, so the biggest integer, which is less than 34.5, is 34. Oh, and the number that's the integer that's less than 34.9999999 is also, here, clear the output, 34. Okay, yeah, that's, so it's truncation. Perfect, that's what we want. All right, things get a little bit weird when you stick a negative sign in front of it. Okay, watch out for this one because you look at this and you go, yeah, I know what X is. X is going to be 34 because what we do is we take the number, you truncate everything, but instead we get 35, which is kind of strange. But you have to remember what I said. The floor function gives you the biggest number, which is less than this value right here. And that happens to be 35, minus 35. So when you start getting negative values, things get a little bit weird. And as a result, if you were to do this calculation right here, negative 34 / b, this would be minus 3.4, but the floor would turn into a negative 4. Okay. When you have negative values, just watch out. It doesn't do what you think it's going to do. Okay. That's the only thing to be careful of. Generally, you just wouldn't use this operator with a negative value. That would be the safest thing. Okay, next one up. Okay, here, toss this one in here. Okay, instead of this one, okay, let's have percent. All right, now the good news is this does exactly what you think it does. Okay, again, everybody has been here. Give me 1 second. I forgot. I've misplaced a piece of paper. Here we go. Just give me one thing. One, okay. No. Sorry, I'm just marking down, make sure I've said that everybody's here. I don't know what they're doing for attendance. I was just told to mark it. All right, so here we go. In an example, we're to use that or floor. Ooh. Okay, that's reasonable. That's reasonable. And this is what I get when I don't show up. Okay. I will give you an example in about 2 or 3 minutes. Okay. Let me cover this module operator first, and then I will give you a real life example where it could be useful. Okay, this one right here, this is not a percentage. This is a modulo operator. This is exactly what you learned in your other programming languages. This is the remainder. Okay, so the remainder when you take 34 divided by 10 is 4. Now, for this, okay, there's an interesting thing. Let me pop open one of these and see if I can draw this out. This is not what I came here to do. I should have had one. So just remember, if you were to take, let's see, 10, oak, 34. Okay. Remember your longhand division? Oh, all right. How many times does 34 go into 10? No problem. It goes in 3 times. You take the 10, you take the 3, you multiply it by 10. This will give you a value of 30. You subtract the value right here, and you do your calculation right here, and you would have a remainder left of 4. That's the remainder. Okay, so it's exactly what you've done. Now, somebody has challenged me to say, give me an example where we could use slash slash or floor. Ooh, 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 ooh. Okay. We will have 235 students in INFS 1201 in the fall. Oh, by the way, hashtags, comments. That's how we deal with comments. No, there's no multi-line comments. This is for those from other languages, looks like this. All right, here we go. In the fall, each class can have at most 24 students. How many sections do we need? There you go. There's a real problem. Okay, so total students, good. Total students, 235. Obviously, you'd probably replace with something like this input, how many students, blah, blah, blah. I'm just going to type the number. I'm too lazy. 235 students. Okay. Room cap. Room capacity. How many students can each room hold? 24. The question is, how many rooms do we require? Rooms required. Okay, very simple. Total students divided by room cap. But we will print this out. We'll say print for F string. You will need rooms required rooms. Bang, here you go. You need 9.79166666. No, no. How many rooms do we need? We need 10 rooms. Okay. How do you get 10? Well, I mean, suppose there's a few different ways how we could do this, and this can sometimes be a little bit tricky to work this out. Okay, but in that case, yeah, we can cover our next thing. If I were to put a +1 here, but you see, then I was to say math.floor, total students, bang. Oh, math is not defined. Yes, because you need to bring the thing in. Okay, import math. Here we go. Bang, there you go. You need 10 rooms. There's a reason why we might use this. Oh, why would I use slash slash instead? Well, because I can save myself the trouble of having to do this, and I could simply say slash slash, and I don't need the import math anymore. Still gives me 10 rooms. Okay, excellent. Now, there's a bit of a downside to this. If I put the number 23, how many rooms do I need? I need exactly one room. Very good. If I have 24 students, how many rooms do I need? I only need one room, but this thing will say 2. Oh, the reason for it, of course, is, well, when you take 24 divided by 24, it's 1 plus the 1. That has one too many. What we would really require here at this point would be, are there leftovers? Oh, in other words, I need an if statement. And what I would have to do is I have to say, if the total students modulo room cap is equal to 0, then the rooms required would need be equal to the rooms required minus 1. And I'm actually pulling away one extra value. Now it looks for this one, if I put 26, well, now I need 2 rooms because I got too many for 1. And in something like 2, that's only 1 room, and it looks after that one weird case. So there's a reason for using a lot of these things. So yes, quite often when we're dealing with slash slash, quite often we have modulo. I know a bunch of you will be going into the cybersecurity course. Or sorry, not course, but program. And in that program, I'm sure you'll learn about cryptography. Cryptography is based an awful lot on this stuff right here. Okay, this is really, really, really critical. I'm wondering if I can do something. Again, I like to diverge of things. Um, mm, yeah, yeah, you know what? You know what? I can do this. Book. Maybe I can. There we go. Site settings. Connection is secure. Manage 3 by. Sorry, I got to remember what I'm doing. Connection is secure. Certificate is valid. Excellent. All right, right here. Details, details, details. Do we see it? Do we see it? Public key. No, because the RSA public key business that's used does actually have a modulo field, and I just don't see it right here. Maybe they've called it something different. They've included the public key, but they don't include the modulo field. I thought it was listed in here. Okay, I was trying to make myself look intelligent about security. But the stuff that actually makes your website secure, yeah, it is actually based on modulo arithmetic. Okay, most of the algorithms usually are. All right. In fact, a lot of things in life are really heavily involved around modular arithmetic and remainders. It's very important. All right, let's get rid of this one. Thank you. Okay. Hopefully, okay. By all means, try to stump me with these. I don't mind. All right, one final one. All right, back. When I used to do this, I used to have a lot of fun, especially back in the world of Java. Okay, x is equal to 2, y is equal to 4, result is equal to x star star y, print result. All right, here is what happens. A lot of students, when they'd hit things like Java, they would look at this and go, yeah, what this is x to the power of y. And it is in some languages. I also see this, by the way, which is a complete disaster. But this actually is x to the power of y. Okay, yeah, it's built in. You don't need to go back and do it. So I don't believe that C++ or Java provided it, but obviously JavaScript does, and I think PHP does as well. All right, so yeah, that is exponentiation. You have to be very careful. That is not exponentiation. That means something very, very different. That's outside the scope of this course. That's a bitwise exclusive word. Okay, we don't cover this, but star star, why? Yeah, it is raised to the power of. Okay, pretty straightforward things. All right. You see what I've got next. Okay. Oh, excellent. Okay, that's how I do it. All right. Next one up. Okay, here we go. Again, I'm going to use a bunch of, okay, well, here, we'll use the same one. Quantity is equal to 10, and size is equal to 2, and total is equal to quantity. No, let's do it this way. Size times. All right, quantity is 10, size is 2, and total is size times quantity plus 2. All right. According to what I see on social media, this sparks an outrage every time when somebody says, what's the answer to this? And nobody can give a straight answer. Everybody's making up their own stuff. You'll end up with one person who will say the answer to this, rid of that decimal point. One person will say, well, what this is 22. Another person will say that it is, let me see here, what we got? 24. And somebody else will say that it's 56 or something, another weird thing. Somebody else will say numbers like this. All right. And of course, the question becomes is what value is it? All right. Well, when you run it, we get a quantity which is a problem. Cool. Nobody told me I misspelled it. Here we go. The answer ends up being 24. Now, if you came up with 56, that means that you do not have enough sleep. Or 3352. It means that you just woke up and just were just guessing. All right, those two are completely out. They're just made up numbers. However, sometimes it's quite what happens is people really get surprised about things. And of course, well, hopefully everybody remembers from the world of math something called PEDMAS, BEDMAS. I call it the order of operations. Okay, in any case, whatever these are. Yeah, remember the way how things are calculated. Things are always done with parentheses first, followed by the multiplication and division. Well, actually, exponentiation first, multiplication and division in order from left to right, and then addition and subtraction order from left to right. Okay, very, very important. All right, so for example, if I said 2 plus size times quantity. Okay, so this one right here. Okay, some people may look at this and they may say, okay, well, it's 2 plus size. So 2, and then we add size to it, which is now 4 in the multiplied quantity, so it's 40, but of course it's 22. And the reason for it is, of course, that, well, you do the multiplication first. So yeah, it uses standard order of operations. You guys have been through this a pile of times. The only thing, okay, you'll notice I've done a couple of weird things in here. Well, maybe you've noticed, maybe you haven't. Students never notice this, but I really notice it. Okay, I'm going to write total a couple of times. And I'm going to try to spell it correctly. Okay, all right. So any difference between lines number 3, 5, and 7? And the answer from a computational point of view is absolutely not. However, from a style point of view, what I've written on line number 3 is actually the desired style. And that is that you leave spaces around pluses and minuses, and you don't leave any spaces around the multiplications. Okay, why do that? I do it to remind myself about priorities, precedence, because stars happen first. I don't put any spaces around them. That's kind of the trick that I use. But in reality, there's actually a set of things in the world of Python called PEP 8 standards. And these are not official rules, but they're guidelines that most people in the programming business follow in terms when they're writing Python. And one of the rules is exactly like this. Okay, use white space around these low priority operators, pluses and minuses. In fact, some I've seen do things like this. I don't really like that. I really like to hold these together. Okay, nobody's going to take your marks off for you. Your program is not going to fail if you do this, but it's something you'll see me end up doing quite frequently. Okay, so here we go. Let's see, 40. Give me 1 second while I find out where I am. 25. Okay. Oh, burned through more time than I wanted to. That's all right. We can stay here all night. No, don't worry, we're not going to stay all night. All right, next one up. Okay. Now, those are some operators. We have some more operators yet. Okay, here we go. X. Okay, I really hate variables called X, but that's fine. All right. The operator right here, that is a greater than symbol. All right, what this will compare the thing before and the thing after, and the result will be one of two things. The result will either be a true or a false. And of course, well, now we've got ourselves a new type called a bool. And yes, bools are true and false. If you're coming from the world of C++, at least they have them now. The original version of C didn't. You had to use ones and zeros, but now C++ does have its own bool type. So yeah, you can actually spell them as true and false if you want. Generally, you wouldn't see things like this. Most of the time, you'll see these relational operators inside if statements or inside loop structures, which we will see in the next slideshow. That's generally where you see them. Okay, but for right now, yeah, this will be good enough to get us started. All right, so is 45 bigger than 50? And the answer, of course, it isn't. That's why it comes back as false. But if I ask the question, is it less than 50? The answer is yes, it is. All right, just as what we've done before. Okay, if you use two equal signs, okay, yeah, 45 is not equal to 50, so that'd be a false statement. Two equal signs, of course, is what you use to find out if two things are equal. If you want to find out if something's not equal, it looks exactly the same as every other language that you guys have seen. Okay, so not equal. All right, the only thing that's kind of a little bit weird is for those who've been through JavaScript, that operator does not exist, which is good. One less thing I don't have to cover. Okay, and neither does that one. So no, it's just these things. It will do type conversion to try and figure out how things, to find out how things would actually end up working. Okay, so do we have other weird things in here we have to worry about? And the answer is, well, no, not really. That right there is asking a question, is 45 bigger than or equal to 50? And the answer, of course, is no. That's why it comes back as a false. All right, next one. And again, you wouldn't normally use it this way. You would include something as part of an if statement. Okay. However, what we can ask is, let's see, x is equal to 67. Okay, let's print, is x bigger than 50? And the answer is, of course it isn't. Oh, wait a minute. Yes, it is because it's 67. Sorry, I typed the wrong thing. All right, so here we go. What else could we ask? Okay, well, quite often you have to put things together. Like maybe you want to know, is it bigger than 50 and is less than 60? Ooh, okay. So, so is X bigger than 50 and less than 60? And the answer is no, it is not. Okay, yeah, you want to find out if it's inside a range. The number 55, well, that is inside the range because it's bigger than 50 and it's less than this. So yeah, the operators here, the good news for those who have just come out of um, PHP, Java, and C++, all of those things use those weird little cryptic operators like double ampersands, double vertical bars, and exclamation marks for and, ors, and nots. Here, it's actually the words and the other word is or, and the word not is actually not. Okay, so it's actually pretty simple. It's much easier than say other things. But there's one little kind of weird thing that you can do. You can't do this in most other programming languages. You can ask a question like this. Okay, and that will actually tell you the same thing. So if I said 45, is it between 50 and 60? Yeah, it works. Is 95 between there? The answer is no. Is 59 between those two values? Of course they are. And yes, if you want to include the equal signs, you want, of course, yes, that's also fine. It just includes the end. Okay, otherwise, it's the same type of Boolean logic that you've seen in other languages. Okay, so nothing really surprising there. Ooh, okay, now this one here, it says to bring up this. Whew. All right, what do the following expressions evaluate to? Okay, I'm going to give you, I think I was supposed to have more time for this, but whatever. We will do these because I think this is actually the last exercise. I don't know if I'll do all of them, but I'll do one or two. I'll let you think about this one for a few seconds. And maybe you want to grab a piece of paper and try to work this out. And then what I will do is I will also work it out. Okay, here we go. So you can see it, and I'll just work something out here on the side. Or at least get started. Oh, and by the way, it comes down to a very simple, it's either true or false. It's actually very, very straightforward. Well, I won't call it straightforward, sorry. It comes down to one of two things. So we got one person who says false. I actually can't remember what it is, but we'll calculate it first. Okay, so one person has done it quick. That's good. Let's see. I've got one already. Yeah. Okay, so we got a consensus at least. Well, I guess it's not a popular vote. It would only be if I get two more people, and then we can win. Now, I suppose what you could do is you could cheat and type it into Python and let it run. Maybe that's what you've done. Or maybe you typed it in the chat GPT. Okay, well, anyway, and again, I can't fault anybody for this. All right, here. Let's pull it over here. All right, just open up a text editor. True, false, true, I guess. Ooh. Oh, now you're confusing me. You're thinking true or false. Anyway, here, let's work through this. Oh, good. Now I've got, oh, true fight. Oh, nasty, nasty, nasty. All right. Well, let's reduce this a little bit. All right. On the left-hand side, I have a mathematical expression. Well, let's evaluate it. using your PEDMAS, BEDMAS order of operations, we'd obviously do the 3 plus 2 first. That's 5. So this first thing would be reduced to this. Okay. All right. And 5 times 4, well, that's 20. 20 bigger than 15 and not false. Okay. Now, the question is 20 bigger than 15? And that is true and not false. This thing right here, not false. Well, that is true. So true, true, and true. And of course, true, true end up being true. Okay. Super cheap way. Bang. Excellent. Super cheap way print. And yeah, we could always just do this. Bang. There you go. True. Okay. Yeah. Okay. Excellent. So that's the way how you evaluate these. Just pull it off one piece at a time. Hey, yeah, we got it right. Okay. So, as I say, I wasn't sure about that. All right. Yeah, fine. We'll do this one as well. Okay. Take a minute to do it. And again, it comes down to a true or false. Oh, and this is perfect because it covers something on one of the slides that I want to cover. Sorry, I'm going to be a few minutes late on this one. But don't worry, you still get your 10-minute break. We'll steal a 10-minute break at the last one if I need to. Okay, so somebody says true. Okay, get another true, and that could certainly be. Okay. Ooh, sorry. This one. Put it here so you can still see. All right, star star 2 is equal to 25 or 10 modulo 3 is less than 2. All right. Now, here's an interesting thing. I am going to evaluate this like a computer. Excellent. All right. You see, the way how a computer would evaluate this is it always evaluates from left to right. Wait, you're supposed to do order of operation. Yeah, yeah, that's true. What it would end up doing is it says, okay, you know what? There's an or here, and there are two clauses. There's a clause right here and a clause right here. If this ends up being equal to true, do I need to look at this answer right here? And the answer is no, I don't. See, I don't need to look at it because I already know. Because if a true followed by anything is obviously going to be true. So here's what a computer would do. It would first of all say, okay, 5 to the power of 2, that's 25, is equal to 25, or 10 modulo 3 is less than 2. It would then look at this one right here and it says, okay, you know what? I'm going to evaluate this one. It's not going to look at this other stuff. It could care less about that. What I'm going to do is I'm going to realize that this is true or 10 modulo 3 less than 2. And because it's true followed by an or, it's completely irrelevant what this other one is. This technique that I just did is called short circuit analysis. Okay, it's used by every interpreter in the planet, including Python, and including any other compiler will also use it. And basically, the idea is that you put things first to make it a bit faster that are more likely to be end up being true because you can end up doing short circuit evaluation. It's kind of a really cool trick. Okay, so that's it. And this one right here, I think just to mix things up, I included a false. I won't give you the time because now you know what the answer is, but you can work this one out. Oh, but you know what? Since we're here, let's do the same thing. Okay, I don't mind doing this one. Here's the operation. 7 plus 3 is bigger than 12, and 2 is less than 4. Okay, how would it do it? Now, here's an interesting thing. You see, the ands and the ors would only be done at the end. Okay, and guess what? It's going to do this one first. Oh, but guess what? The plus has a higher precedence than this thing right here. You have to watch out. Some languages, this is not the case, and you might have to put parentheses around things. All right, so you do have to watch out for it. So 7 plus 10, yeah, bigger than 12, and 2 is less than 4. All right, what are we going to do? We're going to do this one right here. 10 bigger than 12? No, that's false. And 2 less than 4. Do I need to calculate this one? And the answer is no. Because it's an and because the first result is false, I don't need to even worry about the rest. So I'd stop at this point and say the whole thing is false. All right, programming practice. Okay, so here we go. 52. Whoa, okay. I've ended up about 15 minutes beyond what I'm supposed to be. Ugh. Okay. Well, anyway, here's what I'm going to do. If you happen to have the interpreter open, which I hope you do, I want you to write this little program. Now, all it is, it's a whole lot of words. And that's the problem with a lot of these calculations. Yeah, it's a whole pile of words. Basically, what I'm asking you to do is to calculate this formula right here. You have enough stuff to do this. A is the final amount paid for some interest. P is the amount of deposited. R is the number, or sorry, the annual interest rate as a decimal. And T is in the number of terms or the number of years. All right, so I've got a little program here. What it is if you buy a fixed deposit from the bank at a certain interest rate, how much money do you get paid out at the end? Yeah, it's a business type problem, but yeah, that's all right. I want you to try writing a little program. Again, you guys have done lots of these programs before, but this time, of course, I want you to do it in Python. All right, so during the break, you guys get to work on this. Hey, so it's not a break for you. All right, well, it's a break. You don't have to hear me. And it's a break so I don't have to talk. All right, here's what I'm going to do. I'm going to set the timer for 10 minutes. Okay, so once again, okay, that's not good. I see some news. Here we go. I'll set the timer once again for 10 minutes. So I will come back in exactly 10 minutes. I will do a very quick little solution to this. You don't have to share it with me. I mean, I would like you to try it, but I guess I won't hold a gun to anybody's head to do it. But I will take like 5, 10 minutes and I'll write up something for this and I'll talk about what maybe people have done or not done. Okay, so 10 minutes from now, I'll be back. You should use the time for this, but use it for whatever you need to use it for. Okay, and I will mute once again. See you in 10, well, 9 minutes and 50 seconds. Hello. Okay, I'm back. So, I'm not sure if anybody tried. I hope you tried. Okay. If not, I mean, okay, you got the slides. You can go back. You can try all of these things. I have made this suggestion before. Go and play with these things to see how they work because, even switching from one language to another, I mean, it's better than learning a programming language from scratch, but it does take a bit of practice. Okay. And yes, it's quite possible that you'll end up being confused from one to the next. All right, so it says right here, you want to basically do a calculation. A calculation is A is equal to P times 1 plus R times T. All right, and there's one example down here about if you had some calculation. Okay, what is this? Sorry. Okay, we don't need messages from Timu. Okay, congratulations, you have gotten something like that. Anyway, whatever. All right, here we go. I didn't include an example. Normally I do. All right, but here's the idea. If you put in 10,000 riel for 5 years at 5%, I hope to get at least more than 10,000 riel back. So we could probably use that one. Okay, cool. Ooh, excellent. Okay, so somebody's even shared oh, perfect. And yes, you can certainly use an online Python interpreter that you find without having to install anything. I should have also said those. Okay, I'll fix up the slides for next time. Okay, excellent. And yeah, yeah. Congratulations, you did some stuff I was hoping somebody was going to do, which means that I get to complain. All right, but in any case, here, let's do this. Okay, here we go. Bang. So first thing up, yeah, we're going to need a couple of pieces of information. Okay, first of all, we need the original amount. Sorry, wrong screen. Here we go. The original amount, principal. All right, so here we go. So principal, input. How much is the fixed deposit? Okay, and let's see, if you were to ask principal amount, oh, okay, actually you said right there, enter the deposit amount. Very good. That's completely fine. Oh, but if I ran this right now, the type of principal would be a string. So yeah, you're going to need to typecast it. All right, could be typecast to an int, but you'll probably find uh, you probably want decimal points for this thing. All right, here we go. So principal. All right, next up, interest rate. Okay, here we go. The interest rate, float input, um, annual interest rate in percentage. Okay, also as a float. Okay, good. And number of years, float, input, uh, number of years. All right, now, since everybody can see, at least I assume that everybody can see the same thing. All right, so somebody shared with me. And yeah, I no doubt the program works completely fine. However, I don't like the variables. Okay. Now it's a small program. Okay. It really is a small program. And yes, if you just needed to do a quick little calculation just for yourself, it's completely fine to use P, N, R, and T. These are no problem. However, as the programs get bigger and bigger, now you got to remember what a big program is. I have some people who said that yes, they've done some programming in different languages. I don't know how big of a system you guys have ever worked on. I have worked on systems that are around 100,000 lines of code. And when you get to around 100,000 lines of code, we had a variable called S. There was a variable, a global variable called S. It took me 3 years to find it because there was a problem with it. I mean, I didn't spend 3 years looking for it, but at different times I would go, let me see if I can find it. I finally found it. It was like 3 years after I started. If it had, because you can't just search for S because it's too much code and the variable name is too short. If it had been S box like it should have been because it had to do with an encryption algorithm, it would have been easy to track down. That's the problem about using single letter variables. Okay. All right. All right. So we have principal years and the rate. Okay, perfect. So at this point right here, we've asked for each of these things. Now we just need to have the, I'll call it the payout, and the payout is going to be the principal. That's the P times parentheses 1 plus the rate. Now here's the interest. Here's the interesting problem. Interest rate. Now I'm going to write it this way. Good, good. Somebody has that completely correct, but the second one, okay, perfect. You've also got it correct. Again, I just don't like the variables. All right, but in any case, I'm going to write it this way. By the way, I know it's wrong. Raised to the power of the number of years. Okay, and here we go. I'm going to print out the payout. Now, obviously, I should probably put a message around it, say you'll receive this much money in interest. All right, so 10,000 riel, interest rate for 10,000 riel, that's about 4% right now, give or take a little bit, say for 5 years. And it says that year is not defined. Oh, well, it's because it's spelled years. Okay, it happens. All right, here we go. 10,000, bang. Interest rate 4%, number of years, 5 years, and you get back. Let's see, this one, 31,250,000 Qatar rial. Now, if a bank paid me this much, I would be very, very happy. All you put in 10,000, wait 5 years, and then you leave because you've got yourself pretty much $1 million. Yeah, that's a little bit crazy. The reason for it is that, well, the interest rate's supposed to be this percentage, 0.05. There's no shame in doing the following thing, by the way. You can always put a print statement to figure out what things are and exactly how you calculate it. I don't care. For example, I could divide by 100 here, whereas the second picture came up, they divide by 100 here. Both would work exactly the same. All right, let's see whether or not this makes any more sense. 10,000, 4% over 5 years, 12,000. Okay, I kind of believe that. Okay, so you put 10,000 into the bank, they basically give you 2,000 in interest. That's pretty reasonable. Okay, there you go. That's the way how you translate things. I left this one in not because it's really difficult, but it's a little bit of work. Oh, following my convention. Yeah, let's keep that together. Sorry, I missed that one. It's a little bit of work for doing up an expression, pretty simple. And everybody always likes to, in my intro programming courses, to put PRT, but really convert them into something that's more reasonable. Yeah, the program still works, but it's something more reasonable. Okay. Because as you start to get, if you start taking shortcuts on small programs, you will take shortcuts on big programs. Trust me, everybody falls into the trap. I have done exactly the same thing. Okay. All right. So let's get this over to here. Come on. Where's my slides? Where's my slides? My slides are somewhere right here. All right. Excellent. So we've been through all of these. Okay. Excellent. That's that one. And all right. The good news is now we have two out of the way. And if you're absolutely irritated by this whole exercise that we're doing. The good news is that this is the final one. The bad news is you have to listen to me for another 45 minutes or so. I'll see what I can do to finish this one 10 minutes early as well. Or at least sort of at the time. All right, here we go. CPIT 1010 strings is supposed to say lecture 3, but anyway. All right, strings. Yeah, we've actually done a lot of this, so maybe we'll go really quick. So a string is a bunch of characters. Okay, perfect. Yeah, for those who've been through other programming languages like C++ and Java, I did talk about this before that, yeah, there's actually a character type called char, and that would be a character. And of course, you put a bunch of characters together and you get yourself a string. All right, well, in the world of Python, there's only strings. Okay. And what have I got in here? Oh, I didn't put an example. That's not convenient. Oh, I've got the example coming up here. Okay, perfect. I know how we'll do this. All right. I didn't put an example on the first set of slides. So, course name. Okay, CPIT 1020 Python. Okay, it's not really Python, but I know it's a bigger long name, but that's fine. All right, not a big deal. Print course name. Nothing very surprising about this. Every language that you guys have said that you've worked with, you are familiar with the \n because they all have it. And what that is, that's a new line character. And yeah, you don't actually see a \n, but what it is, it's an indication to the system that when they print something, put this back on the next line. All right, there's a couple of other things as well. For example, there is one here called T, which is a tab. I don't know why we keep covering this because the thing really doesn't work very well. New line characters are very, very useful. Um, But what if I want a CPIT 12, 1020 backslash Python to show up? Well, if I do this, now it worked here. Please don't quote me on how these things are going to end up working, because of different interpreters. It might be just a problem with my interpreter. Generally, what you have to do is you have to use two of them. All right. Or what if you want a single quote? Well, what you could do is you could stick a single quote in here. And of course, the problem is if you don't use a backslash, well, then it ends up saying that, well, you terminate it right here, but then I've got something that doesn't make any sense afterwards. Oh, but in the world of Python, I'm sorry, you don't want, oh, okay. I hope you can still see my screen. Let me see. You are sharing the screen. Okay, looks like it. Okay, so here we go. You can always turn this into a double quote. Bang, there you go. And that's how you can put in a single quote. So it's one of those things, it isn't absolutely necessary. The backslash n is very important. There's a few other things that we do use, like the backslash occasionally, and there's a few times where you might need to use an escape sequence for a single or double quote. Okay, so next, somewhere in here. Okay, maybe this button. There, that's the one I'm looking for. All right, next one up. Okay, here we go. Course name. I'll stick to the slide. CPIT 1020. Introduction to Python programming. Oh, okay, well, good. It doesn't go too far. Print course name. Okay, not a big deal. Prints everything. All right, I have to cover a concept called string indexing. Everybody's going to be very familiar with this because every language has almost the same thing. Java does not. Okay, so if you're coming from C++, ooh, C would certainly do this. C++ should have as well. All right, if I ask for square bracket 1, what do I get? What this is from most programming languages, it says go into the string and pull out exactly one character. Okay, and if I run this, you'll see that I get exactly one character, and I get the character P. All right, well, again, everybody's been through the programming languages before. This is really an array of characters. Okay, I can't believe I said that. And of course, what we're doing is we're accessing the character at position number 1. The very first character is at position 0. Okay, so in other words, yeah, that's P. If I was looking to get out the very first character out of the string, it is at position 0. Okay, excellent. If I ask for position number, let's see, if I ask for this one right here, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. If I was to ask for position number 8, I get a blank. Okay, pretty reasonable, pretty reasonable. I'm going to go a little bit further. Okay, I'm going to ask for position number 30. Okay, it gives me an N. Now, the thing is, I don't know which one this is. Let's ask for 31. That's a space. 32. Okay, you see, this is the second big P. Now I know where I am. So this is 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. If I ask for position 42, bang, there you go. Gives me the very last character because there happens to be 43 characters all the way through. Okay, so the very last one is a 42. Okay, excellent. So for those coming from most other programming languages, if you were to ask for 2, okay, should be pretty quick to figure out what that is. That's the capital uppercase I. If I ask for 1, that's the P. If I ask for 0, that's the C. And I'm just going to keep on going for minus 41, or sorry, negative 1. And, well, any other programming language that you guys have listed, that would be some kind of an error. But in the world of Python, it actually gives you the very last character. It's a little weird. Convenient if you're looking for, say, the last couple of things. And yeah, minus 2 is the second to the last character. All right, so now back over to this one, 43. 43 was, oops, sorry, 41 was the N, 42 was the G. And then, of course, I was going to surprise you and say, what do you think we get when you get 43? Because sometimes students think that, oh, it just wraps back around again to the beginning, but actually it doesn't. So if you go too far, it does behave like a lot of other programming languages, it actually crashes. But watch out. Okay, those coming from C++, you're used to that, just saying, yeah, whatever, especially if you learn how to program in C, it would ignore you and just keep on going. It'd be a bunch of random garbage sitting in memory. In Python, everything is checked, but you have to watch out because -1 really means the very beginning. Okay, what else have I got in here? Okay, perfect. I've covered all of these things. Okay, so yes, if you go past the end, you have problems. And if you go way past the beginning, yes, okay, 43, that's a C. But if I go for one extra for 44, now I'm out of range again because, well, I don't have the 44th character before the end. Okay, so there you go. Convenient, sometimes. For pulling off the last character, yes, it is very, very convenient. All right, now I've got some other things in here that are really, really clever in the world of Python. Once you get these things, oh, it is so, so, so nice. However, and especially if you go back and you go back to a programming language like C++, you kick yourself going, oh, why am I using this language? Because it really is a pain in the neck. Really, it is. Okay. So these are one of the things that Python has done really nice, but you know what? There's a cost. I've said it before. Python is not the most efficient language. And some of the features that they provided are the things that make it easy for you, but hard for the program. Well, but the good news is the computers are really fast. All right, but in any case, here we go. Um, I will show you, what do I want to call this? I'm just going to call this something. Okay, print something. Okay, that's not a big surprise. I mean, all that I did was I copied a string to another variable. That seems pretty reasonable. If you're used to old C style strings, yeah, you don't have to worry about that. They are actually they are the same thing. You have to be careful about that. All right, but this kind of makes sense because it looks like you've just assigned the value of the variable to another variable and you're printing that variable. Okay, it's sort of true, sort of not. All right, if I did this, well, of course, we just saw this a second ago. It's called indexing. You can give me one thing, but there's some really, really clever things that you can do in the world of strings. It's called string slicing. Very, very powerful. Let me show you something very, very easy to start with. Okay, 5:10. Looks like you've got like piles of syntax errors, but what I get is 020 space I. Okay, what the heck's going on? All right, well, remember, this is position 0, 1, 2, 3, 4, and right here, this is position 5. This is 6, this is 7, this is 8, this is 9, and this is 10. Oh, so in other words, 5:10 says go to the string and extract the substring starting at position 5 and go all the way up to position number 10, but don't include 10. Okay, there you go. So that's really convenient. It's a really great way of pulling out substrings. So if you know the beginning and the end of a substring you're looking for, this is an excellent way to pull it out. All right, now there's a bunch of really neat things that you can do with this. Like for example, what you can do is you can leave out one of the numbers. If you leave out the first number, it's the same thing as putting a 0 that says go from the beginning and pull out the first 10 characters. In other words, stop just before position 10. Okay, so stop at position 9. So that number is one extra thing. So that's very, very convenient. The other thing you can do is if you give the first number, but not the second number, that's going to go to the end. So it says start at position number 10. Remember, position number 10 is going to be the N, Dro programming, and it's going to go all the way to the end. Really, really convenient. In fact, you can even mix these together with other things, like, for example, 10:-1. Okay, what do you think? Yeah, start at 10, go to the end -1. So in other words, yeah, it's not going to have the G. Okay, so this can be really, really kind of cool. Like give me the stuff that's skipping out the first 10 characters, the last 10 characters. Really, really powerful. This one right here is a little bit weird. Okay, let me put out the 10-20 first. Let me make it 10-30. Okay, here we go. Introduction to Python. Okay, start with 9. Okay, introduction to Python. Okay, Introduction to Python. That's at least a complete sentence. All right, so here we go from 9-31. There's actually a third number as well, which is quite surprising. Normally what happens is if you just don't include it, but if you do, it's included by 1. And what this is, it's called the step size. Okay. If I change this to 2, take a look at what happens. I got itutu octo. Huh? What is this? What this is, it says go into the string starting at position number 9, go all the way up to position number 30. Okay, because you didn't leave out the 31, but take every other character. So the I, the T, the O, the U, the T, the O, the space, the O, the P. That's why we're getting this really funny thing. And yes, if I use like a number 3, that would say start here, give me every third one. For strings, it's not so useful. However, it's very, very useful when we start to get into lists, okay, which are like the equivalent of arrays. Then slicing with this step size is very useful. I don't find it all that useful for strings. Sometimes we do some weird things with it, but not so useful. This is the only other one that's kind of a bit weird, is if you put a step size of -1, it treats that a little bit different. Let me see, 31 to 9 going backwards. Yeah, what this ends up giving you everything backwards. Okay, it's kind of a cool way to reverse a string. Useful? No, no. The number of times we reverse strings is almost everything, or is almost never. Okay, how am I doing? 6:25, and I should be doing this. Okay, yeah, perfect. I'm basically exactly on time. Okay, that's a good sign. All right. Oh, I've done all these. Hmm. The only one that I didn't really cover, oh, sorry, is this and this. Bang. That would be absolutely everything, again, reversed. Okay. Oh, here's something that is a bit surprising, however. Okay, so watch this. Okay, print something is equal to. Okay, that's a little question for you. All right, those coming from C++ will fall into this trap. I think that the rest of you may not. Okay, just give me 1 second. A small technical issue here. Okay, here we go. Now, you look at this and you go, okay, what's going on? I've got this big long course name, CPIT. You know what? Just to make it as simple as possible, here we go. We can just use CPIT 1020. You make something. If I were to print something, no problem. If you were to print it here on line number 3, instead of doing what we're doing, you look at it and you go, it's just going to be CPIT 1020. Excellent. Line number 3, it looks like I'm going to modify the very first character of the string called something and set it equal to X. So it would be XPIT 1020. And then I'm going to print something, which I should see XPIT 1020, and then I should see, of course, the original course name. Okay, excellent. Now, if you think the trick is going to be that you're going to see XPIT 1020 twice, it's actually much more disturbing than that. Here we go. Clear the screen and run it. Instead, this is actually a problem. Line number 3, right here, this is actually not allowed in the world of Python. Once you have a string, you can't change the individual characters. It falls into this category, something called an immutable object, and basically you can't change it. And sometimes this can be a little bit disturbing, especially if you really want to change it. Okay, so unfortunately, you can't do this, not in the world of Python. If I really wanted to have something be equal to the original thing with an X instead, this is what I would have to do. I would have to say it's X plus the course name 1 colon end. Okay, that's what would give this to you. Okay, so you see what I'm doing is I'm not modifying an existing string. What I'm doing is I'm building a new string. Okay, unfortunately, you have to do that. And that's one of the downsides, and it's one of the reasons why things like C and C++ can actually do this type of operations much, much faster. But it comes at its own little problems because you have to set aside enough space to begin with, especially if you're using arrays of characters. And this is true of Java, it's true of C and C++. Arrays are extremely efficient in those languages. They're not as efficient in Python, but maybe we just don't care because the interpreters are fast enough, the CPUs are fast enough. And yeah, there is some truth to this. Okay, let me see what else I've got in here. Okay, string operations. Okay, excellent. Oh, perfect. I've already shown you the concatenation operator. This right here, when you have a string and you have another string, you add two strings together, it's concatenation. Pretty straightforward. I have to show you something, however, that's a little bit weird. Something is equal to course name times two. Uh, Print something. Now, your first glance at this is going to be, well, hang on, that's definitely going to be a problem. You cannot take a course name and multiply it by two. I mean, if we tried this, which I'm pretty sure we did, there we go. Yeah, you can't concatenate. But the strange thing is, this is actually an allowed operator. What it does is it repeats the string multiple times. Okay, again, useful? No. But unfortunately, sometimes we have to cover stuff in these courses that are maybe a little less than useful. All right, so unfortunately, yeah, that's I don't know. Maybe I use it occasionally, but generally you don't really need it. Sometimes I might have something like this. I might say, okay, here's what I might use it for. All right, there you go. It's a quick way of putting 21s without having to type 1. Okay, things like that. Sometimes spaces, initializing strings just to the right size. Sometimes I use it for that, but honestly, it's hardly that useful. All right, here we go. What else have we got? Okay, number seven. We've already talked about that. We already talked about that. It's good. I'm talking about everything before I get to it. Okay, that's fine. Ooh, okay, excellent. So let me go back and let's pop up the slides for a, let's see, this way. All right, so we did string indexing, we did string slicing, including the step size, the start and the end. All right, we've got the slicing examples. I did most of these, so you can read through those, try them, put in your own strings to make a prediction. What they have done in the past on lots of these types of tests is they will have lots of MCQs where it might be, okay, print course name, blah, blah, blah. And then, of course, you have to pick out what is the correct thing. And the tricks are always, does the student remember not to include position number 7? Did they make sure to include the first one? What happens if you got the step size in? So try some of these things. Okay, and of course, it must be string time and int to work. It doesn't work for anything else. You can't say 1 times 4.5. It doesn't work if it's a float. It has to be an integer. Okay, literals. We've already talked about all those literals and modifying a string. I've already done that. And relational operators. Okay. Oh, right. I just ended my slideshow. Ah, sorry. Slideshow. Back to here. Okay. Okay. A is equal to a cat. I might as well use the same example. B is equal to a dog. And I am going to print the relation to find out, does A equal to B? What do you think? True, false, true, false. Is a cat the same as a dog? And the answer is, of course, it is not the same. Okay. Oh, and there's nothing weird, by the way. Those coming from the world of Java. Yeah, sorry, forgot about this. You guys would have to use equals B, right? Yeah, we don't have to worry about it here. Okay, yeah, you can just compare two strings exactly like this, okay? Um, that, on the other hand, is true. Cat is not equal to dog. But then the question becomes, is cat less than dog? Huh? Okay, well, is cat less than dog? And the answer is yes. Okay, good. And if C was equal to an elephant, okay, I guess the question I could ask is cat less than an elephant? And the answer is, here, let me clear it so we make sure we've got it. Yeah, that's also true. And no, it's not talking about the size of the animal. Obviously, Python doesn't have any idea. What we're talking about is lexicographical ordering. Is cat less than an apple? And the answer is no, it's not. Again, it has nothing to do with the size of a cat versus the size of an apple. It has to do with the fact that if you were to put cat, dog, and apple on a list on a page in alphabetical order, which one would come first? Apple would come first, cat would come next, and dog would come next. That's what we're asking here is, alphabetically speaking, is one less than the other. Here we go. Cat and car. Here, okay. So is cat less than car? And the answer is, here, let's clear this one. The answer is, of course not. Okay, because if you were to type these out again in lexicographical order, so here we go, cat, car, and dog, this is not the order you'd put it. A cat would come after a car, but a dog would come later because, of course, well, the letter D appears afterwards. Okay, excellent. Now, does cat spelt with an uppercase C come before car? And the answer is yes, it does. Ooh, why? Okay, what I need to do is I need to remind you of something called the ASCII table. Okay, the ASCII table, sorry, I should have opened one up before. The ASCII table is a list of all of the 7-bit character codes and where things happen to appear. The good news is you don't have to remember these, but there's a couple of really important rules. Like, for example, you notice that the ASCII value for A is 65, the ASCII value for B is 66 and 67 and so on. Everything's kept in order up to Z, and then all of the all of the lowercase numbers come afterwards. Now, do you need to memorize these numbers? No, but I need you to memorize the following things. Every letter increases. Okay, that's fine. You don't need to do anything else. So A is going to be smaller than Z. Always, always, always. The big ones come before the small ones. That's really all you need to know. Oh, by the way, the digits also come before everything, and that can sometimes be really, really surprising. Okay, let's get over to here and let's do a couple of things. A and C. Get rid of this one. And I'm going to put the number 78 and I'm going to put the number 120. Okay, and I'm going to ask the question of you to think about this. When I run this program, is this going to print true or false? All right, so remember what we're asking. We're asking, is A less than C? Well, it's a 78, that's 120. And yeah, that kind of makes sense. I mean, that's exactly what I would want. Okay, however, if I do something a little bit weird by putting quotation marks, and by the way, it doesn't matter if uppercase or sorry, single or double quotes or even triple quotes, if I were to run this as a comparison, it actually comes back and it says, no, it's not. Okay, and the reason for it is because the letter 7 comes before the letter 1. And this is exactly how things would end up being stored if you're to put it into a dictionary, and this can turn into a whole lot of trouble. And you will end up seeing all kinds of weird things being done on the internet in order to prevent this. Like one of the things I quite often do is if I know everything is 3 digits, sometimes what I will do, and I know that there's strings, I will stick zeros in the front because that is now true. 078 is definitely less than 120, but the only way you can compare them is if you happen to have a full string. This is very, very convenient when you're dealing with dates because, for example, 2025-08-03 does come before September 1st. Okay, and that is true. And this is very, very convenient if you have dates stored in this format. That's why a lot of websites you'll see dates stored in this format because it's really easy to work with. You just use a less than operator. If you store it in some other format like 03/08/2025, you can't do the comparisons this way. Okay, so it's very, very convenient for this. Okay. Oh, I didn't get why 0, 7 is false. Okay, let's go back and do this one again. Okay, 0, 7. Okay, I know it was a slightly different thing. And 1, 2. 0, 7. Oh, hang on. A and B. Bing. Now, what I don't know is which one did I have up there? Okay, let me just Control Z this a little bit. Okay, was it this one right here? I think you were asking. Okay, it must mean this one. It must mean 7, 8. Yes. Okay. Perfect. All right. So remember the way how this is stored. Now, I know exactly what I want. Okay. Microsoft Excel. Don't worry. It's not about spreadsheets and formulas and so on, but it's very, very convenient about how I can draw things up. Ooh, bring it back. Bring it back. Okay. You see, I have two strings. I have a string called 7, 8. Sorry, 7, 8, and I have a string called 1, 2, 0. You see, when you store strings, every digit gets put into its own memory cell. So under view and show no grids right click, insert, right click, insert. Okay, here you go. This is the variable called A. This is the variable called C. Okay, and we'll just stick this over to here. All right, there you go. You see, when you have strings, this is exactly how things get stored. You see, this gets stored in position number 0, this gets stored in position number 2, sorry, 1, this gets stored in position number 2. When you sort this, what it would do is it would take and this number would come first in lexicographical ordering because 1 comes before 7. So the way how this works is you compare the first characters first. If the first 2 characters match, then you move on to the second characters. So I think what we'll do is let's write out some strings, 78, 120, 34, 72, 18, and let's sort this lexicographically, but which one comes first? You see, the 120 and the 18 definitely come before that. The 30s come before the 7s, okay? That's the first character sorted, but I might have other things. You see, the second character, hey, that's not bad. 2 comes before 8, it's all right. But this one right here, this is incorrect. So for me to sort it, we'd have to sort it this way. There you go. Now this has been sorted lexicographically. So the way how you sort it lexicographically is you'll make sure that the first digits all match or are in increasing order. And then for any cases where they match, then you have to make sure that you sort. This is the order that things would be sorted, which of course is not numerical sorting because 18 should be first, followed by 32, then 72, 78, and then 120. But when you're sorting strings, it does it character by character. Okay, so it's something you have to watch out for. And no, it's not smart enough to go forward and look. But take a look what happens if I stick zeros in. If I stick zeros in front of all of these, and I say, let's sort all of these numbers again, you see all the zeros have to come first. Oh, sorry, I'd have to put 2 zeros here. All right, so first digit, that has been sorted. Now, second digit, well, this one right here has to go up to the top, then a 1, then this one would, oh, sorry, leave that alone, then the 3, then the 7, that's fine, and then I can sort on the last. There we go. So now everything's being sorted. So this makes more sense when everything's the same, but this is an issue that we have in the world of sorting strings. This happens, I'm going to say, quite frequently. The good news is we usually don't do too much of this in a lot of our things, but we're talking about taking real life data and doing something with it. And quite often what we end up getting is we get a lot of strings as our data, especially if we copy and paste things. And by the way, yeah, oh, take a look at this. You see, they've actually prepended all of these with zeros to make it a little bit easier. But yeah, since these are all strings, if you were trying to sort this, if this doesn't get interpreted into an integer, you're going to end up with these problems. Okay. All right. So that's what was going on here about why things get sorted in a weird way, because what it does is it looks at the first character first. Okay. Excellent. All right, and by the way, it is a tricky thing. All right. Oh, we have one extra thing. Okay. So how about is the string 78 less than 120? Okay, surely that must be true. No, you're not allowed to compare strings and integers. Sorry, they have to be the same type. Okay, I'll be doing 42, 42, 42. I'm supposed to be on an exercise once again. Oh, okay. Let me pop over the slide. I think this will be faster. I'll do. Oh, you know what? Yeah, I can do this. I'll type the same thing. Okay, name. Okay, I wrote down the word Ahmed Al Thani. Okay. Oh, is this useful? This is useful in array and database calling, correct? Yes, yes, yes. Sometimes you try to sort things that you have strings from a database and you have to prepend everything with zeros. That's exactly what it's useful for. All right. What I've done here is I've got a name, Ahmed Al Thani, but you'll notice that I've spelt it in a very, very strange way. That's fine. In fact, I think what I will do, it's a little bit different, but I'm going to stick a T in, or I'm going to stick a dash in here. All right, first one up. Len. That is an abbreviation for length. All right. Yeah, if you've been through JavaScript and Java, you know about a broader property called .length that tells you how many characters. This is exactly what it is. And yes, it includes actually every character in here, including spaces and special characters. 14 letters. Okay, done. That's an easy one. Print name.lower. All right, this is for those who've been through a little bit of object-oriented programming. This is a method. Okay, it actually is a string method. What this will do is it will take the name and it will convert everything into lowercase characters. Now, you have to be very careful. It doesn't actually change the value of the name. It simply returns the string in lowercase letters. Okay. Oh, and guess what? There's one for upper as well. Okay, pretty simple. All right, there's another one in here called print name capitalize. That one can sometimes be useful. What it does is it uppercases the very first word. But there's another one called, what's the other one called? Title. Title is sometimes useful because what it will do is it will go through and it will uppercase the first word of each, or sorry, the first letter of each word. That can be helpful if you're trying to fix some input that somebody has done. Okay, and do I have anything else? We'll have some others we're going to need. But this one right here is not too bad. Replace A and O. All right, these are O. There we go. And I'm going to print it. What this is, okay, make sure I was telling you this. All right, what this one right here does is it goes through and it finds all of the A's and it replaces with O's. So you get a very, very funny looking name called Ahmed Old Thonley. Okay, it sounds like maybe you're having some problems saying it, but this is sometimes useful because sometimes what you have to do is you have to get rid of things. Like I would say, like the most useful thing is by saying, okay, let's get rid of a space. You see, gets rid of all the spaces. Oh, we could also include dashes, but unfortunately, that's not the way it works because what it will do is it will get rid of anything that has a dash in the space. But this can be very useful for getting rid of things. Okay. Like for example, sometimes you want to get rid of spaces somewhere. Speaking of spaces, we have this problem happening all the time, especially if you're coming from the world of web programming. Unfortunately, you never know what somebody has typed into an input box. And if I ask you to print out the length of test, the answer is not 5. You see, the answer is 12 because what includes all of the spaces here, all of the spaces here. And often, people include spaces at the end of things. It's a habit. All right, but what I can do is I could make a new variable and I could say test.strip. And what that will do is that will get rid of the spaces at the beginning and the end. Very, very useful for dealing with web programming. Maybe not a lot of other things. Now you might say, okay, well, so it's just for web programming. No, remember, you guys are going to be going into one of two streams I've talked about before. It's either cybersecurity or you're doing data science. If you're into cybersecurity, one of the things you're going to be doing is you're going to be writing programs that read log files. Log files are filled with all kinds of nasty stuff. There's new line characters at the end. Sometimes there's spaces all over the place, and you have to sanitize it to clean it up. The second thing is if you're a consultant, people include extra things like quotations to try and do things called SQL injection attacks. You have to be able to process these things by cleaning up the really nasty stuff that's coming in. You're looking for backsticks. You're looking for backslashes, you're looking for semicolons, all of these types of things. All of these tools I show you here, that's what it's used for. If you're in data science and AI, you're going to be pulling data from who knows where, and you're going to be asked to analyze it. Quite often, what you have to do is you have to clean the data and stripping away characters at the end and at the beginning. And sometimes you just have to do it because the data sources have some dirty data to begin with. Your intro DSAI course, you'll definitely be doing that type of stuff. Ooh, okay. So we've got one final thing over here as once I find my stuff, it says here, got a small programming exercise. Unfortunately, I didn't have a chance to really write it up all that well. So I think what I will do is rather than giving it to you to do this, I think I'll do it. Okay, and I'll give you some ideas about how and why you might want to do one of these. So what it is, it's you've received some kind of a messed up message. It's backwards and it's being tampered. Hey, stop it. Back. It's been written backwards and it's been tampered. So, like, for example, here's the message right here. The real message is hello world, but you can see that you have to read it this way. You have to ignore the spaces at the beginning and at the end. And of course, we've got all these digits to deal with. So let's write the program that can deal with this thing. Okay, so here we go. No, no save, no save. Here we go. The message was equal to, oh, give me a second. I'm not going to type that. Okay, there we go. Easy message. Now, of course, what this could be, it's probably actually from an input, right? Okay, I'm just lazy because I don't want to deal with input. I'm more interested in discovering other things. All right, let's clean this thing up. First thing up, message is equal to message.strip. What would it do? And then we're going to print. Ooh, okay, print the message. Okay, now I'm going to ask you a question. Did I get rid of the spaces? We can tell that the spaces at the beginning are gone, but we don't know about the spaces at the end because, I mean, they're just spaces. Are there invisible spaces here at the end? The answer, by the way, I don't think there is, but here's something often that I end up doing. Okay, print, quote, message, quote, sep is nothing. Okay, so what does that do? Well, what it will do is it will print the message and it'll put quotation marks around it. You see, now I can see the spaces. I find this really, really useful. So rather than just print message, I'm going to do that one instead. Oh my. Okay, cat fight going on outside the window. All right, here we go. So now you can see that I got rid of it. Sometimes this can be really, really useful because if you have extra characters and you have no idea what's there, and sometimes this can really cause some trouble. All right, so here we go. Print message strip. Okay, next thing up, let's get rid of the digits. Okay, now this one can be a little bit funny, and I'm going to show you a few different ways how to deal with it. You see, there could be any digits. Now, there might be other ways, but remember, there's some replace functions. All right, you see, I can replace a 4. Boo, boo, boo. I can replace a 4 with nothing. Oh, hey, that's pretty cool. But the problem is I don't know what my message has. But not only do I have to replace 4, I also need to replace the 9. Replace 9 with nothing. And yeah, okay, so it's not bad, except it's going to be a real pain in the neck, isn't it? All right, I could actually chain it up this way. Message dot replace 1, replace 2, replace 3. I'm going to do it this way instead. I'm going to say message is equal to message dot replace, and we're going to do 9 this way with a slash. Okay, same thing. All right, so really the only thing I have left to do is, okay, Okay. All right. I'll do enough and then we'll come back to it. All right. You see, I have no idea what's coming. So yes, I'm going to do a 0. I'm going to do a 1. I'm going to do 2, do a 3. I'm going to do 4, do 5. I'm going to do 6. I'm going to do a 7. Ooh, not an enter key. 7. I'm going to do an 8. I'm going to do a 9. And I guess that's it. Bang. Perfect. We got it. Ooh, it looks kind of ugly, isn't it? Okay. Well, you know what? That's fine. Um, I always say, if you copy and paste something once, it's okay. If you copy and paste something twice, you're probably doing it wrong. Okay. And yeah, this is obviously one of those, yeah, you're doing it wrong. Okay. And yes, I am aware that there's an awful lot of things that I could be doing a lot better. We will use a loop next time to fix it, and we will try to fix this with a loop because that's what we use loops for, is to avoid repetition. All right, but for right now, we don't have loops, so we'll do it afterwards. Here we go. Message is equal to, now we need to flip the entire message backwards. Okay, no problem. That was message colon colon -1. That was a string slicing. And of course, if I now print the message, bang, now we have ourselves hello world again. And obviously, I can replace this with anything at all, like with an input, and it will get rid of all the digits. Okay, it was painful, but it did work, and it will get rid of the trailing stuff and the leading stuff. That's good, and it will flip it around afterwards. Okay, and really the only thing left to do is just to remove these extra print statements. Print statements are very useful when you don't know what's going on. You just want to see how things are going. Okay, let's see. Indexing. Okay, back over to here. Okay. Sorry, let's go from here. Okay, string indexing we've covered, string slicing we've covered. We did all of these examples. We did the string operations. I showed you what happens if you try to modify. We talked about the lexical ordering. It's something to be careful of. Generally, just don't try to compare strings. You'll be okay. Unfortunately, sometimes you do want things, but it just happens to be in logo graphical. There we go. Lexicographical order. Okay, sorry about that. It uses ASCII values, so all capital letters are small and lowercase letters. All right, string methods. Okay, we did the lower, upper, capitalize, replace. I did the strip, but I didn't do the find or the count. I, okay, I know that I'm on limited time, and in fact, I can see I'm down. I'm way beyond what I'm supposed to. Obviously, I can't cover everything. But what I do is I make notes as I go through saying, hey, you know what, next time let's not do this one. Okay, so I'm just covering what was there already. And split, I can't cover split yet. I know those who've been through Java have seen the split, especially if you took our CP courses from us back when we were CNAQ. You definitely have seen this. And yeah, we will be doing this, but I don't have any need for it until I hit list. So I don't want to confuse anything yet. I'm already confusing enough. All right, and of course we did our one little programming exercise, and of course that was the end. All right, so there we go. That was the first set of slides. I'll give you a little bit of preview about what's coming. So at least you can say like, oh, okay, it's going to be again another boring one, especially if you've been through Python. Okay, I'll answer the question here in a second. If you want, go ahead and type the question and I'll get to it in a second. And let's go take a look at what I've got here. And I can show you the stuff that I was given in terms of what we've got to cover. So we have a course introduction and basics, yeah, YAML operators and expressions and some strings. That was today. Tomorrow I'm going to cover looping. Okay, yeah, while loops and sort of general looping structures. We're also going to cover for loops and we're going to do a little bit of stuff on functions. The next day we're going to be talking about variable scope and parameters, and we'll move on to list basics. Too bad I couldn't get the functions together. We'll do list basics and sort of more complicated lists, and then we will deal with something called tuples and sets and basic dictionaries. This one right here, and this one right here, and this one right here, probably like what I would describe as like the really most important things. Okay, and these are the things that are probably the most tricky to deal with. Okay, so that's what's coming, and the same thing is if we. Okay, thank you. That's a good question. I'm going to give you what I think I understand. Okay. All right. So, unfortunately, because this was a very last minute thing, I was picking up information at the very last minute. Like, I think I've got it, and I apologize if something very, very strange happens, but let me try my best to answer that question. All right. But in any case, that's what's coming over time. So, tomorrow it's going to be looping, for loops, and writing basics of functions. Okay. So, that's what's coming. I've got the slides, I think, just about set up. I will put up in the D2L. I've already sent a message asking them to find out why you can't log in. So, maybe by tomorrow we've got it. The online editor or any online editor you want to use is completely fine. All right. And I will make these available. I can't make these others available because they're actually not finished yet. They're partially finished. That's why they're here. Okay. So that's what's coming up. All right. So you came up with a very, very useful and important question. How do you pass this course? Okay. So what I got from the person who put the course together says, there's no assessment through the course. There's one final exam at the end. The final exam at the end was mostly tracing Python code, and I think they asked the students to write one program. That I don't know. Unfortunately, I don't have an answer to that one yet. Here's what I would like to do. I know that there's a final exam, and you give me 1 second because there was a whole bunch of questions that popped up about the exam dates. So here we go. The end date, exam dates, exam says the 25th of August. Okay, there you go. On the 26th of August, there will be a final exam. 25. Okay, that's the Monday. Okay, that's the Monday after we finally get started, before our normal courses begin on the 26th. All right, so there's one final exam. You need to score a 70%. I don't know the time yet. Okay, sorry, I don't have a time yet. Okay, don't worry, we will figure this out. And I know that some people might be taking more than one remedial course. Again, I don't know the answer about what the timing is. Okay, so as soon as I find out, or hopefully somebody just tells you directly. So sorry, I don't know the answer to that yet. So I wish I knew the answer. So sorry, I don't. All right. When it starts to get really close to this, like the week before, like on the 21st, if you have not gotten some kind of an answer already by email, by all means, you send me an email and you say, hey, tell us when the exam is. I still might not know, and I might not know until 24th. Okay, but I promise on the 24th, we will definitely know. Oh, by the way, second thing is because it's kind of a weird little thing. I mean, we are meeting just for the 4 days and very, very intense timing. Um, I will be available by email from now until August 25. Okay. So if you have a question, anything to do about Python, you can send me an email. Just remind me and say, hey, I'm taking CPIT 1020. Because if you don't say that, I might think that you're a regular student and I might not answer until later. But just say, yeah, I'm taking this course, or I took this remedial course from you. I was having problems with this, and I don't mind replying. Okay. All right, so 70% on the one test at the end. Let's see, the feedback from the instructor who did this one time before said it was really quite easy. Everybody except for one passed. I don't know what the situation was for the student who didn't pass. He said that, you remember, the test is really, really quite simple. Okay. I would almost say that it's probably going to be a little bit easier than, say, my INFS 1201 test, which is really meant to test you, and they also have lab exams. What I'm thinking is you probably have to do at least one programming exercise, maybe two, and then there'll be some MCQs where basically it's what's the output of this program. Okay, those are the types of things. So it should be a relatively simple thing. Sorry, I don't know the timing. I assume it's 2 hours, but I don't have an exact detail. I don't know if it's a morning, evening. The only thing I have is the date, which is the 25th. But as I say, I will be around and I will certainly help anybody by email. Okay. So sorry, I couldn't quite answer this question, but I think I got close. I think at least I have the how do you consider this a pass? I've heard that it's 70% on the on the one assessment. Okay. Anything else? And was it of any use? For previous exams or exercise to practice on. Okay. I okay, here's a bit of a problem. Okay. Um, I'm not opposed because the question is can I provide you with some previous exams or exercises to practice on? Not directly, because I think this course has only ever happened once. However, what I have no problem giving you are the INFS 1201 exercises. I will give you all of the lab exercises from INFS 1201. Now, those are a little bit heavier weighted for one thing. For example, when a student in the undergraduate program comes in, they take a course called INFS 1101. And in INFS 1101, they cover basic things like strings, loops, variables, operators, and expressions. And in 1201, I do a repeat of loops and functions, and then I do lists, tuples, sets, and dictionaries. I do sort of the more difficult ones. I will give you guys access to the exercises from 1201. I'll find all of the lab exercises and dump them out for you. Okay, I will make sure that goes into D2L. If you don't have access to D2L by tomorrow, I will share it to you here within the chat within here, or I'll set up another web page somewhere where you will have access. Okay, so thank you. We mark that one down, and I will have that for you tomorrow. Okay, so exercises from 1201 to this group. Okay, these will be all the lab exercises that they do. I might even include some solutions. If the solutions are there as part of the zip file, then I'll make that available as well. If not, we can always ask ChatGPT. I think the answers will be there as well. Okay, it's no problem. Okay, anything else? We're going past time. That's good. I know we don't have anything else. Okay, so what we're going to do is we're going to say